Yeah, I started. All right, Stuart Cannery will package tomato juice in 2-liter, which is 2,000 centimeter cubed, cylindrical cans. Find the radius and height of the cans. If the cans have a surface area that is less than 1,000 centimeters squared, we have this formula here. It says revisited because I guess we were supposed to visit this at some point.
Yeah, at some point in time, but that's okay, and I'm trying to stay one step ahead of the game. And there's 2 ways actually you can solve this out. So,
one way
is to find the x-intercepts, but set up the equation there, Mrs. Stevenson.
Okay, so we have 2 pi r squared plus 4,000 over r, and we're saying that needs to be less than 1,000. So what we would do is we'd subtract the 1,000 over to the left side, so that now we have a less than 0 situation going on. And because we have a less than 0 situation going on, we can graph this and find the x-intercepts and then look at where the graph is below the x-axis.
So 1 at 0 is 4.619. And again, we'll leave all that alchemy stuff up to the, to
3
the
decimals. 3 decimal places,
people.
please.
Yeah, 3 decimal places. So 9.654 or 555. Let's go 55.
How many 5s?
2s.
Okay,
2 5s.
okay. So these are our x-intercepts, and if you graph this, you'll see those x-intercepts there, and then you see the graph dipping below between there. And I think it's a, does it look kind of like a parabola?
Yeah, it's parabola-y, but not quite.
Not quite. So what we care about, though, since this is where the x-axis is it is less than 0 between those 2 values.
Right.
You said there was another way of...
The other thing that you could do on this is you could go ahead and leave that 1,000 on the right-hand side.
Oh,
and you could graph the line 1,000.
Right, and find the intersections.
And find where the 2 intersection points are.
For me personally, though, it's a lot easier to figure out where the x-axis is, because normally it's just right there in front of your face.
Yeah, I agree. I agree 100%.
You would definitely have to do some zooming if you make it equal 1,000. But you may not have to if you do the x-intercepts.
Right. So what we want to do, though, is we want to find the radius and the height of the can.
We just found the radius. How do we find the height?
We've got 2 radiuses there. So the height, how do we find height?
Well, if it's a cylinder...
Be 2 pi r squared h. That'd be the volume.
Oh, yeah, and they told us that the volume was 2,000 centimeters cubed.
Right.
So we can plug the radius in. Oh wait, there's 2 of them. We can get a range of values.
Yeah, we can get a range of values.
The first one. And then plug in the second one.
Right. We're going to end up with 2 different guys.
And again,
here.
we'll have a range of values.
Right.
So we need to do some calculator work.
Oh,
Mr.
I'm on
Calculator.
So that would be 2. Can we we're going to solve for h, right?
Right.
So I'm just going to do the whole shoot match at once. So 2,000
divided by parentheses
2 pi
2 pi
and times
4.619 squared.
619 squared.
Close your no, don't close your parentheses first.
Yeah.
Okay.
Right.
Okay.
I got 14.919.
Okay. And then here, you just have to, if you put it in one time all at once, then you should just be able to edit what you have and put in 9.655.
I feel like something's not right, though, but that's just me. I could be butterfingers on the ball here. 9.655.
Oh, why did we put 2 in front?
Why did we put 2 in front?
Isn't
it's the height of the cylinder.
Which is pi r squared h.
Pi r squared h.
There's
okay,
no 2.
so no 2. So I'm going to just do times 2 then. So I get 29.83 on the first guy.
29.83.
And 6.829 on the second guy.
Is there a reason there was only 2 decimal places there?
838, sorry.
8 or 9?
8, 9.
6.
We do this for a living, so
nope.
0.6829.
6.829. Okay, so and that's a range of values. So
right.
Our range for our radius, which those are both in centimeters, by the way.
Right. And so our range is going to be between these two values, 4.6 and the 9.65. And so as a result then, when you're looking at the height of a cylinder, well, if we have a range for the radius, we could end up with a range for the height as well.
Yes, exactly. And these are both centimeters as well.
A lot of stuff going on in this section. We've shown you several examples
Of how to do a sign chart. Sign charts are should be your best friends because they're pretty stinking awesome.
Yep. So get comfortable with them and lots of practice.
Yeah, make sure that you remember to type in the code word into your Turnitin. It was somewhere in the video, I'm sure. So type it in to Turnitin. And thanks for watching, as always.